Okay, so this is chapter 7, which is all about designing experiments. So remember, with experiments, we are going to be able to draw those cause and effect conclusions that we cannot draw with those observational studies. So let's talk about why. All right, so with an experiment, then we've got some terminology. So some critical differences that do allow us to draw those cause and effect conclusions. So we have what's called the treatment. The treatment is also referred to as that independent variable. So remember that the independent variable, this is what we manipulate so that we can then essentially measure what happens as a result of that manipulation or that exposure to the independent variable. So for example, we might want to do administration of a drug. So we have some people who are placed on a diet or exercise program for 6 months, and then their blood pressure is compared to people who do not diet or exercise. So in this example, then blood pressure is the outcome, right? That's our dependent variable. And we're saying that blood pressure should depend on if you are in the diet or exercise program or not. Okay, so it should depend on exposure to that manipulated independent variable of diet and exercise program. So that's one of the things that allows us to draw cause and effect. Additionally, experiments also use random assignment. So they randomize the subjects, so the participants who are in the study, to the treatment or to that independent variable. And by doing that random assignment, we can balance out some of those participant characteristics that participants bring to the table. So that's another way that we can help to establish cause and effect. So experiments then, on the whole, we're going to compare the response. So comparing the response to a given treatment compared to maybe another treatment, compared to no treatment at all. So a control group, right, where there is no exposure to that independent variable, or potentially to a placebo, which is a fake treatment. So when there are confounding variables that we can't randomize, so for example, gender, right, could be a confounding variable that cannot be randomized. It could be fixed or controlled. So sometimes you'll hear in certain studies that they'll talk about, we controlled for the influence of gender in studies where we know that gender makes a difference. So for example, if we were studying depression, we know that women are diagnosed with depression about 2 to 1 compared to men. So if we were doing a study on depression, we would want to control for the influence of gender because we know that it makes a difference. So there are some statistical ways that we can do that. All right, so let's talk about that placebo effect. All right, so placebo effect, remember, we're talking about no treatment, right? So we're giving someone kind of that fake treatment. So oftentimes we do still see improvements, right? That if patients are given even a fake treatment, that oftentimes they do better, right? They kind of magically seem to improve. And there is some research that shows that there are actual changes in neurobiological pathways as a result of exposure to a placebo. So your book talks about the therapeutic results being about 35% of patients improve following placebo, but this is likely an underestimate. It's probably actually higher than that. And so there's also something called this negative placebo effect, which is essentially the opposite. So labeling an active drug as a placebo. So if I tell you and you're part of a study that you're getting a placebo, even if it's not, even if it's the active drug, we actually find that it reduces the effectiveness of that particular substance. So things to be aware of when you are interpreting the literature around experiments. All right, so let's talk about some additional issues in terms of design. So in designing an experiment, there are several things that we need to be mindful of to help help us maintain that integrity and the ability to draw cause and effect conclusions later on down the line. So one of the things that we want to do is control bias, right? So control bias as much as possible. So bias can happen during experimental studies when we are expecting some kind of particular outcome. So for example, from the participant perspective, if I am getting a placebo, but I don't know I'm getting a placebo, well, then I'm expecting that I'm probably getting a drug, right? And I'm going to improve. There can also be bias on the side of the experimenter. So if as an experimenter, I know which group is getting the placebo and which group is getting the actual drug, well, then I might have some kind of bias, and maybe I'm looking for more improvement with the group that's getting the drug compared to the group that's getting the placebo. So that can be a potential confound within an experimental study. And so one of the things that we do to get around that is what's called blinding. So with blinding, the experimenter or the participants, okay, so in this case, if it's a single blind study, either the experimenter or the participants don't know which condition they are in. So they don't know if they're getting the placebo or if they are getting the real active drug. So they don't know, they are blind to it. In a double blind study, both the experimenter and the participants don't know who is getting what, okay? So no one essentially knows who is getting the placebo and who is getting the actual treatment. So one thing to keep in mind here, though, is that the subjects have to be informed that they could be potentially getting one of a number of different possible treatments, and they have to consent to participating in the study, kind of no matter which of the treatments they might be randomly assigned to. Obviously, otherwise, we would have some problems with research ethics, which would not be a good thing. All right, so let's talk then about some of the challenges here with applying results from research studies to real life. So remember that one of the goals of doing research is so that we can take what we find about our sample, that small group, and apply it to the population or the large group. Okay, so that's our goal, to generalize. To do that, then, of course, our sample has to be representative of the population. So remember, for your sample to be representative, it has to be similar to the overall population in those important characteristics. So these are typically demographic factors. Depending on what you're studying, it might be maybe risk factors, medical conditions, all of those things. We want to make sure then too that the treatment that we are researching, if it's appropriate for the response. So looking essentially at, will exposure to this independent variable help us address the dependent variable that I am interested in studying? So if you look here at this particular study where the FDA is recommending doses for certain sleep drugs. And so they essentially did the original studies with all men. Okay, so the original research study here was done with all men, and then they made some kind of distinctions here that maybe women's bodies process this just a little bit differently than men, and so perhaps the results from a study of all men does not generalize to the full population if we are including both men and women in the full population. Perhaps the results only apply to men. Okay, so this could apply here as well if we look at animal research. So carcinogen studies, looking at carcinogens in lab rats, and that the results don't always apply to humans. So what we find in animal research may not necessarily always apply back to actual human beings. So we need to be careful then, right, in terms of generalizing. All right, so let's talk about some additional types of experimental designs. So one of the types of experimental designs that you might see is something called repeated measures. So repeated measures, the measure or the exposure to the independent variable is repeated. So the same person is experiencing the independent variable in random order, okay? So let's say that I'm testing maybe two different types of drugs. I get drug A first, and then I get drug B. But other participants in the study would get drug B first, and then they would get drug A, okay? So the same person is getting exposure to essentially all levels of the independent variable in the study. So you have multiple measures for each individual person. And then with matched pairs, we are matching, as the name suggests, pairs, right? So matching pairs of participants. So we choose two people who are very, very closely like one another. So twins are a good example here. And then we randomly assign twin 1 to this condition and twin 2 to that condition. And then we're going to compare those twins, right? So they're like a matched pair to determine the effect of the treatment. All right, so just in terms of looking forward in your textbook, so part 1 is all about exploring data, so that's those graphical representations, but also about collecting data, so how to set up research studies. Part 2 is about exploring the data and being able to draw inferences, so taking what you find in your study, in your data, and using that to draw some kind of conclusions. And then of course the statistical inference, part 3, is using those statistical procedures to draw different types of inferences. So remember, for example, with correlation, we can only say that two variables are related, right, to one another. That's an inference that we can draw based on a statistic. Whereas with an experiment, we can use, for example, a t-test or an ANOVA to look at differences between groups and then draw some kind of inference about the efficacy of different types of treatment, right, or different types of drugs. So you'll see then that when we're looking at kind of this movement from exploration to influence, when we're in the exploratory data analysis phase, we're really just kind of looking for things that stand out, right? Looking for those types of interesting patterns, looking for some types of informal conclusions kind of based on just what we see in the data, okay? So looking at it and trying to make sense of it. But of course, with statistical inference, we are taking it one step further. We're drawing these much, much more formal conclusions, and then of course, trying to generalize or apply those conclusions from our sample back to the population. We're also typically trying to address some kind of very, very specific research question. And those questions, of course, are put into place before we ever collect our data. And that's part of doing good research.